Welcome friends and welcome to my series of video lectures on theory of structures. In today's lecture, we are going to start the topic of portal frames. The topic of portal frames is related to the course outcome CO TOS E, which is related to application of moment distribution method for portal frames. So in this lecture, we are going to get introduced to the topic of portal frames. In this lecture, we will be covering the definition of portal frames, then classification of portal frames, and two questions at the end of the lecture. So we will start with our definition with an example, practical example. This is a very familiar picture of a framed building structure which is multi-storied and multi-bayed. There are 7 stories, 1, 2, 3, 4, 5, 6, 7, and there are bays. Bays means sections. 1, 2, 3, 4, 5, 6. So there are 6 bays. Now there is a combination, or you can say assembly, of columns and beams. At every story we get a floor. This floor may be of a floor slab or some material like that. Now at the bottom of every column there is a footing. So this is a very common structure, a frame building structure. Now if we look at this frame, which is actually this frame, you can see this frame. You can look at this structure as a series of such frames. This is 1, 2, 3, 4, 5, 6, 7. So there are some 7, 8 frames which are making this structure. So it is a combination of individual frames like this. So this becomes a 7-storied plane frame, and this structure becomes a 3-dimensional structure by assembly of these frames together. So this frame will be called as a portal frame. This is the object of our study. So after having seen a practical example of frame building structure and the plane frames, plane portal frames in it, we will go to the definition of frame. So this portal frame is an assembly of rigid jointed beams and columns. The definition of a portal frame is this, that it is an assembly of rigid jointed beams and columns. We will understand this definition in a greater detail now. First thing, it is an assembly of beams and columns. You know that beam is a horizontal structural member supported on vertical structural members called columns. So beams are supported on columns. Beams are horizontal, columns are vertical. Both of them are straight and usually they form a rectangle. So a portal frame is an assembly of beams and columns, but an important condition is that it is having rigid joints. The joints between the beams and columns are rigid. Now the meaning of the word rigid joint is that at that joint a beam and a column, they are not free to rotate. They are not free to rotate, so they have to bend in order to resist the load. This is in contrast with a pin joint where the rotation of the members is allowed, and in that case there is no question of bending developed in the members. The members are subjected to axial tension and compression, and these pin joints are used in pin jointed frames, usually the truss frames. So this is a rigid jointed frame. This portal frame is a rigid jointed frame, so it is totally different than a pin jointed frame of a truss. So the definition of portal frame is it is an assembly of rigid jointed beams and columns. Now the portal frames are of various varieties. We can get a very simple portal frame to complex portal frames also. They can be complex in their shapes and they can be complex in the configuration of the beams and columns involved in it. Now in multi-storied and multi-bayed buildings, we can have complex portal frames. In this study right now, we are going to consider a simple portal frame. A simple portal frame will be consisting of just 2 columns and 1 beam, that's all. And supported at the bottom, the columns will be supported at the bottom, and accordingly we will be calling that frame as a simple portal frame. Now coming to the classification of portal frames. Now the simple portal frames will be classified in two types, in two classes. One is called a symmetric portal frame and the other is called as unsymmetrical portal frame. Symmetrical and unsymmetrical portal frames. Let us understand the meaning of the word symmetrical portal frame. In order to call a portal frame as a symmetrical frame, it has to satisfy symmetry in 3 points. So first is geometrical symmetry. It has to be geometrically symmetric. Means that the members should be symmetrically dimensioned, as well as their properties also should be identical or symmetric. Then the second condition is that symmetrically supported. It is not enough to have geometrical symmetry, but they should be symmetrically supported, and the third thing is they should be symmetrically loaded. If a frame classifies all these 3 conditions, it is essential that all these 3 conditions should be satisfied, not only 1 or 2. Then this frame will be called as symmetrical frame. Otherwise, it will be called as unsymmetrical frame. Any frame which does not satisfy even one of these conditions, it will be termed as a unsymmetrical frame. Now we will take some examples of symmetrical and unsymmetrical frames so that we can understand these 3 types of symmetry clearly. So here we see some 4 frames. Now we will classify them accordingly as symmetrical or unsymmetrical. All the frames are simple frames. They are made of 2 columns and 1 beam. Let us start with frame A. Now, if we look at frame A, it is geometrically symmetrical. That means the 2 columns are of same length and there is a beam. Now, you can have a line of symmetry here and you can fold on this, so you can see that both the sides will be identical, so that this frame is geometrically symmetrical. There is another point in geometrical symmetry. The dimensions should be symmetric as well as the moments of inertia. This is 2i, this is 2i and this is I. You know that moment of inertia is related to the cross-sectional dimensions. So this column and this column, both of them are having moment of inertia 2i, whereas the beam is having moment of inertia single I. So this means that the columns are of same moment of inertia, so there is a symmetry in cross-sectional dimensions also. So this is all about geometrical symmetry, dimensions and moments of inertia. Then the second point is symmetrically supported. Look at the supports of this frame. You can see that at the bottom this column is supported by a fixed support, this column is also supported by a fixed support. So only 2 supports and both of them are symmetric. Supports are symmetric, so we can say that this is symmetrically supported. The third is symmetrical loading. We know that the frame will be called as symmetric only if it has got symmetrical loading also. So you can see this UDL W, this vertical UDL W as the symmetric loads on both the columns, and this P, load P, is a concentrated or point load which is applied at the center of the beam, so that it is applied symmetrically to the entire frame. So we can say that this frame A is symmetrical from all the 3 points of view. Now let us go to frame B. Look at frame B. B is having geometrical symmetry in terms of the dimensions. The 2 columns are of same length, but first column is having moment of inertia I, the other is twice I. So the two columns are not symmetric. There is a violation of symmetry in this point. Secondly, the load, you can see the support conditions. One support, left support, is a fixed support, whereas there is a hinge at the other support. So it is not symmetrically supported. Then third thing is loading. There is only one load and it is symmetric. It is only on the beam. So the load wise this frame is symmetric. So still we will finally call this frame as unsymmetrical because it does not satisfy the first two conditions. Let us go to frame C. Frame C seems to be symmetrical in all the respects other than the load. The dimensions, the geometry and the moments of inertia and everything and the support conditions all are symmetrical, but the load is applied at P only on one column. So this means that the load is applied unsymmetrically on this frame. So this is an unsymmetrical frame. Let us look at the fourth example D, which is also an example of obvious example of unsymmetry. You can see here that every time, about every point, this frame is unsymmetrical. First of all, dimensions are unsymmetrical. Two columns are of unequal length. Secondly, the supports are different. One is hinge support, the other is a fixed support. Then the loading is also unsymmetrically applied. So we can say that this frame D is unsymmetrical from all the 3 points of view. So now with this you can get a clear idea about what is unsymmetrical and symmetrical portal frame. Now it is important to understand why are we classifying the frames as symmetrical and unsymmetrical. What is its significance in the analysis? The significance is that whenever a frame becomes unsymmetrical like this, look here. This is a frame which is symmetrically loaded, symmetrical in geometry and supports, but it is unsymmetrical in load. This load is unsymmetrically applied. Now due to this unsymmetrical loading or unsymmetry of frame, this frame will have a sway. The word sway means sideways displacement of frame. So the frame will have to bend like this and there will be a sideways displacement of the two joints and this will be called as a sway frame. So the symmetrical frames will not have any sway. They will never have any sway. Look at this frame. They will not sway towards left or right. They will not have that sort of displacement. So unsymmetrical frames are sometimes called as sway frames also, and symmetrical frames are also called as non-sway frames. The sway analysis is a different mathematical analysis required for analysis of unsymmetrical portal frames. This is for our information. In our chapter we are not going to consider the sway frames. We are going to consider only non-sway, that is symmetrical frames. But this was for the understanding of the classification of frames. So in this lecture we started with the definition of portal frames as assembly of rigid jointed beams and columns. Then we classified the frames as symmetrical and unsymmetrical, and we tried to understand the exact meaning of symmetrical and unsymmetrical by these 4 examples. We also understood that there is a sway in case of unsymmetrical portal frames. Now we come to the end of the lecture and we are having 2 questions to understand whether we have really followed the whole thing. First question is, distinguish between a pin jointed frame and a rigid jointed frame. This is an application level question. Second question is, draw 3 unsymmetrical frames, of course other than these 4. So draw 3 examples of unsymmetrical frames. This is also application level question. So friends, this was an introductory lecture on the topic of portal frames. I hope you have understood the content. Do solve the questions at the end of the lecture. Goodbye till the next video.